So this problem is based on conservation of energy. The bob has been released from this position, and in absence of any non-conservative force, the bob would have reached this position. But the problem states that there is air resistance. Air resistance is a non-conservative force. So a part of the energy of the initial energy of the bob will be lost to overcome air resistance. So it will not be able to rise to this position. According to the problem, it has been able to rise only to this position. Okay, so I will apply the formula del U plus del K equal to WNC. Change in potential energy plus change in kinetic energy equal to WNC. Del U is what? U final minus U initial. Del K is what? Kinetic energy final minus kinetic energy initial. WNC, the non-conservative force involved in this problem is the air resistance. So I will write it as air resistance. Okay. UF, final potential energy. UI, initial potential energy. Now you know potential energy formula, gravitational potential energy formula is mgh, and this requires a reference, that indicates h equal to 0 position. So I will take, you may take this position as h equal to 0 position. I am taking this position as h equal to 0 position. This is h equal to 0 position. That means we'll measure height above this line. Okay. So what is the initial potential energy of the bob? It is mg. I am writing final one. Final height is 0. Initial, yes, yes, very much. And initial is initial height. Now take this to be L. We know L equal to 1.5 meter, but we'll put its value afterwards. So this one is L. This one is L cos 60. So initial height is L cos 60. L cos 60. So mg into L cos 60. I am writing the entire equation in terms of L and M, then I'll put the values, numerical values afterwards. Now final kinetic energy, you know this is the highest position to which the bob can rise. So obviously final energy, kinetic energy will be 0, and initial kinetic energy, the bob is released from rest, so initial kinetic energy is also 0, and this is equal to W, work done by, okay, work done by, this is work done by just look at the problem. You have been asked to find work done against, but what you are getting here is work done by air resistance. So W, air resistance, or minus mg into L cos 60. Cos 60 is half, equal to work done by air resistance, or now put the values, m equal to 8 minus 80 into L. I have taken g equal to 10, L equal to 1.5 into half, work done by, okay, this one is by air resistance, because the formula gives you work done by non-conservative force, or the answer is how much? 15 15 into minus 20 or 60, 15 into 8, 15 into 4. Is it okay? So I think all of you have understood this. Work done by air resistance is Work done by air resistance is minus 60 joule, but that will not be your answer. Hence, work done against, right, work done against air resistance equal to plus 60 joule. Okay, so I think all of you have understood this.